When someone asks you to name the world's leading nation in railway manufacturing, China almost certainly comes to mind. Today, Chinese-built rail systems operate in over 100 nations worldwide. From the sprawling networks of Argentina to the desert railways of Egypt and the modern lines crisscrossing Turkey, Chinese electric multiple units have become fixtures of daily commuting. This global footprint represents one of the clearest demonstrations of China's industrial capabilities on the world stage. Yet as China's railway reputation has expanded internationally, so too has the competition grown fiercer. Recently, Mexico's government announced a major rail procurement initiative valued at $320 million. The outcome surprised many industry observers. A Chinese manufacturer emerged victorious, outbidding Spain's CAF and outlasting France's Alstom to claim this substantial contract. Under the agreement, the trains scheduled for deployment are projected to transport as many as 50,000 passengers daily once operations commence. What factors allowed China to win Mexico's confidence? And what circumstances led France's Alstom to step away from this high-stakes competition? Before we explore these questions in depth, if you appreciate the content we produce, please consider subscribing to our channel to stay updated with all our latest investigations and reports. Now let's dive into today's story. Mexico City stands as one of Latin America's most significant and fascinating urban centers. The cityscape presents a remarkable fusion of ancient civilization remnants alongside colonial-era monuments, all within one of the planet's most densely populated metropolitan areas, home to more than 20 million residents. Beneath this vibrant, bustling surface, however, lies a collection of challenging urban problems that have plagued the city for decades. Much of Mexico City's foundational infrastructure traces its origins back hundreds of years to the Aztec capital that once occupied this valley. As modern expansion accelerated, cultural preservation laws prevented the demolition of numerous historical structures, making comprehensive road network redesign nearly impossible. Walk through the city's neighborhoods today, and you'll observe infrastructure in perpetual renovation mode. Road repairs, metro maintenance, drainage system upgrades. Somewhere in the city, construction barriers and detour signs are always present. Even minor vehicle collisions can trigger traffic paralysis lasting half an hour or longer. The statistics paint a sobering picture. During peak traffic periods, traversing merely 10 kilometers within Mexico City requires an average of 32 minutes. Rush hour commutes take 60% longer than trips during off-peak times. The cumulative effect means each resident loses more than 150 hours annually to traffic delays, consistently placing Mexico City among the world's most congested urban centers. You might reasonably ask, if roadway congestion reaches such extreme levels, why don't residents simply switch to rail transit? The answer reveals much about Mexico's transportation history and cultural patterns. Mexico's national railway infrastructure has historically prioritized freight operations above all else. While rail tracks extend throughout virtually the entire country, passenger service has always occupied a secondary, marginalized position. For most Mexicans, personal vehicle ownership became the default transportation mode generations ago. The situation worsened dramatically during the 1990s when Mexico privatized its railway system. Following privatization, passenger routes were progressively discontinued and eventually abandoned entirely. Over the subsequent decades, rail travel simply disappeared from the Mexican transportation mindset. Long-distance travelers opt for air travel. Short-distance commuters drive themselves. Rail transit became not just uncommon, but virtually irrelevant to everyday life. Although recent years have seen government initiatives promoting what officials call a railway revival, significant challenges persist. Many newly constructed passenger lines suffer from disappointingly low operational speeds. Several don't even qualify as high-speed rail by international standards. Consider the Maya train, which opened its doors at the close of 2024. Its maximum velocity reaches only 160 kilometers per hour. Globally, genuine high-speed rail systems operate at 300 kilometers per hour or faster. By this benchmark, Mexico's rail infrastructure appears outdated and sluggish. These limitations prompted the Mexican government to announce an ambitious new railway construction initiative. Between 2025 and 2030, authorities plan to build approximately 3,000 kilometers of passenger rail lines, the most extensive expansion program in Mexico's railway history. Our story's centerpiece, the Mexico City to Pachuca rail line, represents a crucial component of this broader vision. The Mexico City-Pachuca Railway connects the nation's capital with Pachuca, the capital city of Hidalgo State. The project encompasses approximately 106 kilometers of electrified double-track railway designed exclusively for passenger operations. Unlike Mexico's traditional freight-focused approach, the Tren Mexico-Pachuca project explicitly prioritizes commuter needs. By dedicating the line entirely to passengers and avoiding shared tracks with cargo trains, the system ensures consistent operating speeds and reliable service frequency. Trains on this route will operate at speeds between 120 and 130 kilometers per hour. The alignment passes through several heavily populated communities, creating a continuous corridor from Mexico City through to Pachuca. Total project investment reaches approximately 5 billion pesos. Preliminary planning concluded in October 2024, with groundbreaking ceremonies scheduled for March 22, 2025. But any railway system's success fundamentally depends on the trains themselves. Passenger comfort and operational safety represent non-negotiable priorities that demand rigorous attention. Mexico has traditionally acquired its rolling stock through international competitive bidding processes. This procurement would follow the same transparent approach. The three-way competition, Europe versus China. Three major manufacturers entered the bidding competition: Spain's KF, France's Alstom, and China's CRRC. Each company brought substantial credentials and international experience to the table. The question became, which manufacturer would Mexico ultimately select? During the project's early clarification phase, France's Alstom demonstrated exceptional interest. The company submitted significantly more technical questions and clarification requests than competing bidders, suggesting deep engagement with project specifications and requirements. Industry observers interpreted this activity as evidence that Alstom viewed the contract as strategically important. Then came an unexpected development. Alstom withdrew completely from the bidding process. While official statements provided no detailed explanation, industry analysts generally attributed the withdrawal to several possible factors: concerns regarding contractual terms, challenges with cost projections, complications related to local manufacturing requirements, or reassessment of project-related risks. Whatever the precise reasoning, Alstom's departure left CAF and CRRC to compete head-to-head. Both remaining bidders submitted comprehensive proposals addressing all technical requirements. However, CRRC decisively outperformed CAF in two critical evaluation categories: pricing and technical scoring. The cost-effectiveness criterion, which received particular emphasis in the bidding documents, became especially decisive. CRRC's winning bid totaled $320 million. CAF's competing offer came in at nearly $270 million higher, approximately 1.8 times CRRC's price. More significantly, CAF failed to demonstrate any meaningful technical or performance advantages that might justify the premium pricing. Given this straightforward comparison, the Mexican government's choice became clear. CRRC would supply the trains. What China will deliver: technical specifications and requirements. Under the contract terms, China assumes responsibility for designing and manufacturing 15 electric multiple units. Each train will measure approximately 100 meters in length, achieve maximum speeds of 130 kilometers per hour, and accommodate roughly 700 passengers. The rolling stock must integrate seamlessly with the Mexico City-Pachuca line's electrified double-track infrastructure, which utilizes an overhead catenary power supply configuration. Additionally, Mexico explicitly required all trains to incorporate the ERTMS train control system compliant with European technical standards. Many readers may be unfamiliar with ERTMS, the European Rail Traffic Management System. This unified framework consists of two primary components: ETCS, which stands for European Train Control System, and GSMR, or Global System for Mobile Communications, Railway. ETCS monitors train velocity and positioning through wireless communication protocols. The system operates across three progressive levels. Level 1 maintains traditional trackside signaling elements. Level 2 transitions to wireless communication infrastructure. Level 3 relies entirely on wireless systems to control train operations. Meanwhile, GSMR provides dependable wireless connectivity, ensuring continuous real-time information exchange between trains and centralized dispatch operations. Throughout the past decade, ERTMS standards have facilitated safe, efficient cross-border railway operations across Europe while accelerating the continent's rail network modernization. Mexico's decision to adopt these European standards reflects a commitment to world-class safety protocols and international interoperability. The project timeline presents considerable challenges. Construction officially commences in March 2025, with the Mexican government scheduled to release a 20% advance payment in September to initiate manufacturing processes. The complete line must open during the first half of 2027, requiring all trains to be delivered no later than the end of 2026. This aggressive schedule demands more than simple manufacturing efficiency. CRRC cannot merely export completed trains from Chinese factories. Instead, the company must establish local component production facilities within Mexico, coordinating with domestic supply chains while navigating Mexico's legal and regulatory framework. The requirement for local manufacturing presents both logistical challenges and strategic opportunities. Beyond one rail line, the broader vision. Some observers question whether new trains serving a single route can meaningfully address Mexico City's massive congestion problems. This perspective misunderstands the project's strategic significance. The Mexico City-Pachuca Railway represents far more than isolated infrastructure. It functions as a cornerstone initiative within Mexico's railway revival strategy and serves as a national demonstration project. The line's successful completion will prove to both domestic and international audiences that Mexico possesses the institutional capacity to construct modern passenger railway systems. Equally important, the project establishes templates and standards for planning and developing a future nationwide rail network. Daily ridership projections estimate up to 50,000 passengers, offering citizens genuine transportation alternatives to private vehicles. By integrating railway service with existing bus networks and urban transit systems, the project contributes toward building a more efficient, environmentally sustainable, and modern transportation infrastructure throughout the region. Perhaps most significantly, the railway will forge effective connections between Mexico City and Pachuca, facilitating bidirectional flows of industries, workers, and resources. Currently, Mexico City suffers from extremely elevated housing costs and severe population density pressures. Meanwhile, Pachuca and broader Hidalgo state offer comparatively lower living costs, alongside substantially greater development capacity. Once the railway becomes operational, travel time between the two cities will shrink to under 70 minutes, enabling the formation of an integrated super-metropolitan zone. Core urban resources, employment opportunities, educational institutions, healthcare facilities, can expand outward from the capital. Hidalgo state gains capacity to absorb population overflow and industrial development that Mexico City can no longer accommodate. This dynamic creates win-win scenarios, reduced pressure on the capital, while accelerating economic development in neighboring regions. This contract does not represent CRRC's inaugural collaboration with Mexico. In July 2022, CRRC undertook the comprehensive modernization project for Line 1 of the Mexico City Metro system. The company accepted responsibility for design, manufacturing, and delivery of 29 AM22 trains. The entire line extends approximately 19 kilometers, with total investment reaching $2 billion. Operations are scheduled to fully commence in November 2025. Unlike the Mexico City-Pachuca Railway project, CRRC's involvement in the Line 1 upgrade encompassed nearly every project dimension: track engineering, train manufacturing, and system integration. Essentially, CRRC managed the complete project workflow from start to finish. Notably, despite the large-scale infrastructure upgrades, the project avoided disrupting normal metro operations. Between 2022 and 2025, construction proceeded through a carefully phased approach. Eastern and western sections underwent renovations separately, while remaining segments continued serving passengers. The portions completed first have now operated successfully for several years without a single safety incident, handling nearly 1 million passengers daily. Through this demonstrated real-world performance, CRRC has already earned recognition and trust from the Mexican public. When the Pachuca Railway contract came to bid, CRRC didn't arrive as an unknown quantity. The company brought a proven track record of delivering complex rail projects on time, on budget, and to high safety standards. China's victory in this procurement competition reflects broader trends in global infrastructure development and international economic relationships. Chinese railway manufacturers have spent decades building technical expertise, achieving economies of scale, and developing comprehensive project management capabilities. These advantages translate into competitive pricing without sacrificing quality or safety standards. For Mexico, partnering with Chinese manufacturers offers access to proven technology at sustainable price points. The cost differential between CRRC's bid and European competitors wasn't marginal. It represented savings that could fund additional infrastructure projects or extend railway lines to more communities. In an era of constrained government budgets, cost-effectiveness matters enormously. Yet price alone doesn't tell the complete story. CRRC's willingness to establish local manufacturing facilities, transfer knowledge to Mexican workers, and integrate with domestic supply chains creates long-term value beyond the immediate project. These partnerships build local industrial capacity, generate employment, and develop technical skills within Mexico's workforce. The adoption of European ERTMS standards demonstrates Mexico's commitment to international best practices and future interoperability. As Mexico continues expanding its passenger rail network, trains equipped with standardized control systems can eventually operate across multiple lines, creating truly integrated national railway infrastructure. This technical choice positions Mexico for long-term success as passenger rail service expands throughout the coming decades. So, the path forward contains both challenges and opportunities. CRRC faces tight delivery schedules and, the complexities of establishing manufacturing operations in a new country with different regulatory environments. Coordination between Chinese engineering teams and Mexican construction crews will require effective communication and, honestly, a good deal of cultural understanding. Local supply chain development may encounter unexpected obstacles. Currency fluctuations, international shipping logistics, and global supply chain disruptions all present potential risks. However, successful project completion opens doors to future opportunities. Mexico's railway revival strategy envisions 3,000 kilometers of new passenger rail by 2030. If the Pachuca line succeeds as a demonstration project, CRRC positions itself favorably for additional contracts. Other Latin American nations watching Mexico's experience may consider Chinese railway manufacturers for their own infrastructure needs. The project becomes a showcase for Chinese railway technology adapted to Latin American conditions. For Mexico, success with the Pachuca line validates the railway revival strategy and builds momentum for continued expansion. Demonstrating that modern passenger rail can be delivered on reasonable budgets and timelines strengthens political support for additional investments. And as rail service improves, changing transportation habits becomes easier. Success really does breed success. Beyond economic considerations, the railway project carries environmental and social significance. Rail transportation generates substantially lower per-passenger emissions compared to private vehicles. As 50,000 daily passengers shift from cars to trains, Mexico City's air quality benefits measurably. Reduced vehicle traffic means less congestion, shorter travel times for those who continue driving, and lower fuel consumption. The social benefits extend beyond environmental gains. Affordable, reliable transportation increases economic mobility. Workers living in Pachuca or Hidalgo State gain access to employment opportunities in Mexico City that were honestly previously unreachable due to commute times and costs. Students can pursue educational opportunities across the metropolitan region. Families can maintain connections despite physical distance. Transportation infrastructure fundamentally shapes quality of life and economic opportunity. This railway line will meaningfully expand possibilities for hundreds of thousands of residents. Urban planning experts increasingly recognize that transportation infrastructure influences settlement patterns, economic development, and social equity. The Mexico City-Pachuca Railway demonstrates how strategic infrastructure investments can reshape regional development patterns, addressing both immediate congestion challenges and long-term growth management. The $320 million contract represents more than a business transaction between Mexico and China. It signals Mexico's determination to reverse decades of railway neglect and build modern passenger rail infrastructure comparable to systems in Asia and Europe. The project demonstrates that emerging economies need not accept second-rate transportation systems or remain dependent on technologies from previous generations. For China, the contract validates years of investment in railway technology development and international market expansion. Chinese railway manufacturers didn't achieve global competitiveness overnight. Success resulted from sustained commitment to research, quality improvement, and customer satisfaction. Each successful international project strengthens China's reputation and opens doors to future opportunities. The collaboration between Mexico and China on railway development exemplifies how international partnerships can deliver mutual benefits. Mexico gains access to advanced railway technology at competitive prices while building domestic industrial capabilities. China expands its international presence while gaining valuable experience adapting technologies to diverse markets and regulatory environments. As construction begins in March 2025, attention will focus on execution. Can CRRC meet the aggressive delivery timeline? Will local manufacturing facilities achieve required quality standards? How smoothly will European control systems integrate with Chinese rolling stock? These questions will be answered over the coming months and years. When the first passengers board modern electric trains traveling between Mexico City and Pachuca in 2027, they'll experience more than comfortable, efficient transportation. They'll witness the culmination of strategic planning, international cooperation, and really, sustained commitment to infrastructure modernization. The railway line represents Mexico's determination to address urban challenges through thoughtful investment rather than accepting congestion as inevitable. China's victory in this procurement competition demonstrates that technical excellence, competitive pricing, and proven reliability create winning combinations in global infrastructure markets. European manufacturers may need to reassess their competitive strategies as Chinese companies continue expanding international presence. For millions of Mexicans, the ultimate measure of success will be lived experience. Whether the trains run on time, whether the service proves reliable and safe, whether the railway genuinely improves daily commutes and expands life opportunities. If the Pachuca Line succeeds in these practical terms, it will catalyze Mexico's railway revival and prove that modern passenger rail can thrive in Latin America. The rails being laid between Mexico City and Pachuca carry more than trains. They carry hopes for reduced congestion, economic development, environmental improvement, and enhanced quality of life. As steel tracks extend across the landscape, they forge connections between communities while building pathways toward Mexico's transportation future. The journey has just begun.